Surely, all cubes are made of sources. Here are sources. If you open a folder contrib, and then you have a cube folder, and there it is. Here you can see a make file which is responsible for compiling your code. You can see control file cube control which describes your extension. Here you can see SQL files that are executed as a SQL code, and header files and C files as a main code of your extension. And finally, you have some folders for tests which are executed when you run command make check inside the cube folder or command make check world inside root of the repository. What's inside makefile? Makefile just organizes whatever is around. One important thing here is that you have to register regression tests inside the makefile to make them runnable during make check command. File cube_data_h describes structure ND box, which is a n-dimensional box, which is a header of any cube data. First, there is a 32 bits for length of the specific instantiation of cube. Then you have 32 bits for header, and then you have double precision floating points which represent different values of cube vectors. The header is responsible for 1 bit of is your cube point or is your cube actually cube with 2 vectors. And other bits are bits of the dimension mask. And inside the other bits we store information on how many dimensions your cube have. Here you can see some service macros which are responsible for checking is your cube actually a point, how many dimensions have your cube, what's your lower left chord or upper right chord, and setting these chords respectively. Inside the C file you have so-called module magic. This is a macros imported from Postgres headers, and its most important point to check if your extension was built against appropriate version of Postgres. So when your dynamically loadable code is loaded to Postgres process, first it checks functions that were created by PG module magic and asks what is the version of Postgres which you are compatible to. There may be other function called pginit, which is called from your code and which is responsible for setting your functions to internal hooks. To export your functions to be visible from Postgres, you have to use v1 convention. Prior to v1 convention, there was v0 convention, which was just exporting functions with regular C prototypes. But with v1 convention, you have to specify macro prototype pg function info, which create export prototype for your function. And when you prototype your function, say func name here on second line, instead of parameters, you use pg function args macro. And after that, you can use specific macros to access parameters of your function. I highly recommend you using only v1 convention as for now, and some features will be unavailable if you don't use v1 convention. For example, you can't create set returning function like dblink, which returns a lot of rows if you don't use a v1 convention. Along with your compiled code, you provide SQL file which is responsible for describing your functions to the database. For example, here we are creating a function cubeIn, and we are denoting that it's accepting one parameter as string, that it's written in language C, that it's immutable, so don't change, don't have side effects, and some other attributes of a function. Inside SQL file, we also create operators. Here we create a taxicab distance operator, which is responsible for calculating Manhattan distance between two cubes if they are connected with commutator smaller hash bigger, something like this. And here we have other prototype for penalty function, which was described previously. And at the end, we can describe operator classes to inform core that some specific type may be indexed by, for example, gist. And for indexing, we have to use some specific implementation of union function, of consistent function, of compress and decompress functions, and some others. Now that's it for Cube, and let's discuss some other extensions.